Okay, it's 9:40, so let's get started. So just a few announcements. Quiz 4 is out, so if you haven't started, please do. It's due on Saturday, just like the other 3 quizzes were, and homework 2 is also out. And the first part, I believe, is due Sunday night, and the second part is due the following Sunday. Any other questions before we start? Or any questions before we start? Good. Any questions about material? Anything you're confused about? Anything? Ryan, what's your favorite color? Anything?
What's the meaning of life?
What's the meaning of life? I had when I was a freshman in high school, in the final exam review, someone asked the teacher that question, and the response was, the meaning of life is the search for the meaning of life. So very deep philosophical question, but yeah. I don't think we can cover that in 50 minutes. Any other questions before we start? Probably more geared toward this class. Okay, so what was the major thing we talked about in lecture last week?
Regular expression.
Yeah, these things called regular expressions, right? So how do I define a regular expression? So what things are regular expressions? Let's start easier. What are the simplest possible regular expressions that I could possibly have?
Empty set.
What's that?
The empty set.
Empty set, yeah, that's one. All right, well, which has language, empty set. What about other ones? Are there others?
Yeah. Empty string.
Yeah, empty string, yeah.
You have a single character.
Yeah, and a single character. So a single character for all characters in the alphabet that we're considering. Okay, so those seem like basic building blocks, but how do I build larger ones from smaller ones? What was that? Yeah, concatenation was one of them. So if I have 2 regular expressions, then their concatenation is also a regular expression. So we use the circle to mean concatenation with R1, R2 regexes. What other ones can we build? What other regular expressions can I have?
Union.
Yeah, union, right. So instead of just doing concatenation, I can do union. So R1 union R2, with them being random. Anything else?
Star.
Yeah, star. So if I have a particular regular expression, say R1, I find the star of it, that's also a regular expression. Actually, the star should go in here, but it really doesn't matter in this case. So with R1 regex. Okay, so it seems like a nice inductive proof. I have small things and I can build larger ones from the small things. Why do we care? Why should we care about these things? Well, it seems like they have a way of describing some language, right? I just say 2 small things, do the union, 2 small things, do concatenation, do star. And then basic building blocks from there. It seems like a way of describing things, but again, why do we care? We're studying regular languages at this point. Why do we care about these things? We can describe the languages, but do these things have anything to do with regular languages? Ah, yeah. From a regular expression, can I make an NFA for it? Yeah, we'll see how to do that. What about the other way? Can I make, from an NFA, can I make a regular expression? Oh, okay. So these things not only can describe languages, they describe the regular languages. So instead of having a machine, I can actually describe a regular language to you without using English or something like that. Okay, so that's the main reason why we care about these things. They can describe the regular languages. Okay, so let's actually do some of the problems. So the first one is I have this regular expression, AA union BA star. I assume the alphabet is A and B in this case. And I want to make an NFA for it. So how do you think I can go about doing that? Well, I think maybe the definition can help us a little bit here. So let's see. If I can make the small building blocks, if I can make an NFA for those, could I make the entire regular expression? Well, what is the last operator that's being applied here? Star, that's the last one. What's the second to last one? Which one? Union or concatenation? I'm doing I'm doing union second to last, right? And then the next one is concatenation, obviously. So, do you agree with me that if I can make an NFA for just a single character, A, and a single character B, could I make an NFA for the whole thing? Yeah, because we know how to do concatenation of two NFAs, we know how to do union, and we know how to do star. So let's do all that in one exercise. So, can I make a single character A, NFA that accepts only a single character? Could I do that? And nothing else? Just a single character. Yeah, I have a state and transition on A to where? Some final state. What does that final state do? Well, it's final state, but it does nothing, right? I better not accept anything else after that point. Okay, so maybe we can go along that route. Let's have a single character A, NFA there. And I think you can agree with me that I can barely modify this to have one for B, right? I can just modify the transition to be just the single character B instead of just A. Okay, so now we actually can make an NFA for each part. Now we know that we can make an NFA for the entire thing, so let's actually do that. So what's the first operator that's going to be applied again? Concatenation, right? So I think let's do AA first, and then we'll do BA. So how would I do AA? Be careful.
Remove the except state of the A and use the epsilon.
Ah, okay. But I'll show you a wrong way first. That's what I do. Does this NFA accept the regular expression AA? Yeah. Is this the one that I want? No, why is it not? Because this isn't concatenation of the two NFAs corresponding to one corresponding to A and the other one corresponding to A. So something that'll really help you here. What are these? Are they characters or are they regular expressions? Yeah, I think this single character A and this one, they're both regular expressions. They're not characters here. So when I say AA here, I'm saying the concatenation of regular expressions here. So I think I want two copies of the NFA corresponding to that regular expression, then we can do concatenation of them. So let's have two copies of AA here. And then the suggestion was, how do I do concatenation of these two NFAs? Yeah, epsilon transition from where to where? The final state of this one to where? Start state of the next one. Yeah. So I'm going to make a transition on epsilon to here. Is that it for this one part? No, what do I have to change? A final state to be non-final. Yep. Good. And I think, again, BA is going to be very similar to this. So I'm just going to put it right here. So B epsilon A except. Okay. Cool. So now what do I do? What's the next operator? Union, right? So I think once I have an NFA for this, I do, and an NFA for this, I can do union. So let's do it right down here. AA union BA. And so I think a good idea is just to copy and paste my NFAs, the two NFAs right here, down into here. So that's what I'm going to do. Oops. Should be a state. A epsilon A B epsilon A except. Okay. Well, how do I do the union of these two? How do I do union really easily with NFAs?
Epsilon transitions and
So I'm going to have a new start state, an epsilon transition into the two old start states, right? Because I can choose which one to take. So I'm going to have an epsilon transition into the old start states of the two machines. Okay. Very, very simple. Just the things that we've seen. Okay? Am I done with the whole problem? No, what have I forgotten? Star, right? So purely for the interest of time and space, I'm gonna do the star right on the NFA right here instead of redrawing everything all over again. Oh, this is nice, man. So I'm just gonna do this in a different color to make it obvious. So how do I do star of an NFA? Yeah, so it seems like I got to go through the machine again, and it seems like final states to start states seems like a good idea. Is there a problem with that?
Yeah.
It'll be fine here, but in general.
Wouldn't it imply that you have to go to the machine once?
Well, I'll make the start state final because I need to accept the empty string, right?
Okay.
The problem is if I covered this last week, but I'll cover it again. So if I have a DFA right here, and let's say it has, say, two final states, what do I have to do to that start state? And first of all, let's make sure, let's just say that it has a transition on A to some other state and back to itself. What do I have to do to that start state if I wanted the star? That's the suggestion, but the suggestion was earlier to come back to the start state. But what do I have to do to this start state?
Make it a final state.
They don't final state, right? Because I have to accept the empty string, and this is a DFA, so there's no other state other than the start state I can get to. But now I've accepted more strings than I wanted to, right? So I can't do that. But the suggestion is let's come back to a new start state that is also final. So I'm going to make a new start state that is final. Then how do I hook up this new start state to the rest of the machine? I think an epsilon transition from it to the old start state because I have to be able to start where I originally was without having read anything. Okay, and then the suggestion of coming back to this new start state is a valid one. So I come back here, and let's see if I can meander through. Anything is possible up here. Okay, so this really is how you do it. So you just say, okay, I have regular expressions. How do I do the concatenation? And we know how to do that. How do we do union? Is just new start state epsilon to the two old start states. And star, make a new start final state. And epsilon transition back, epsilon transition in. All right, it's just the things that we've seen. But it's just a simple conversion from regular expression to n. Any questions on this? Okay, So let's do the other conversion. I have an NFA over there, and I want to make a regular expression out of it. So how in the world are we going to even do that? Is there something we saw that we could use for this? Yeah, these G NFAs. What's a G NFA? But like, what's the acronym mean?
You know, like generalized?
Yeah, generalized NFA. What's the generalized mean?
So the transition can be a regular expression.
Exactly. Instead of having a single transition on each, a single character on each transition, I can have an arbitrary regular expression on it. Okay, well, why do we want GNFAs? Well, suppose I had an NFA that looks like this. And it has some regular a GNFA, sorry. And it has a regular expression on the transition like this. What is the language of this NFA, this GNFA? Yeah, it's just R, right? So, oh wait, R is a regular expression. So the regex I want is just R. So if I can get to that situation, then we're all set. But how do I guarantee I can get to that situation? Well, notice, is there anything coming into the start state? Nope, there's nothing coming in. What about anything leaving the final state? Yeah, there's none. How many final states are there? There's only one. There happens to only be one here, but notice there are things coming into the start state and leaving the final state here. So this thing is not a GNFA yet. So I gotta convert it to a GNFA. So right here, I'm gonna convert to GNFA. And so how in the world am I gonna do that? How do I guarantee that nothing will ever enter the start state? Oh, yeah, we can add a new one, right? And so we hooked it up like we did over here without these other epsilon transitions. But barring those, there's nothing entering the new start state that we just made. So that seems like a good suggestion. So I'm going to call my new start state QS. And I'm going to leave the rest of the machine untouched for now. So B, oh, worry about that transition in a second. B, okay. I think this transition, A comma B, that means that I can either read an A on that transition or I can read a B on that transition. But each of the things on these transitions now is going to be a regular expression. So how do I express A or B as a regular expression? A union B, right? So it means the same thing, but I want to get into the mindset of writing regular expressions on the transition. So it'll just be easier for me. Okay, well, how do I hook up this new start state to this machine? I got to have an epsilon transition like as before over here, right? Because I want to be able to start as if I haven't read anything. Oh, wait, we haven't fixed the problem of the final state yet. There's something leaving the final state. So how do I fix that? Add a new final state, okay. So, not again, but add a new final state I'm going to call QF. Q1 better not be final anymore. But how am I going to hook up QF with the rest of the machine? Epsilon transition from where? All the old final states, but it was only Q1 before, so I just do that. Okay. Okay, so I have 5 states now, and I want to get down to a thing that has 2 states. So how am I going to do that? I guess we're going to rip states out, right? How many states am I going to rip out in a single step? Only one, yeah. I want to make this as simple as possible. Any choice as to which one to remove? Q2. Does it matter which one you picked? No, it doesn't matter what order you picked. So let's rip Q2 out. So I'm just going to erase this. We don't need it anymore. Rip Q2. So all of the other states are going to obviously still be there. QS is going to be there, Q0, Q1, and QF over here. And I think all of the transitions that don't involve Q2 are still going to be there. So B, A, and I think those are the only ones. If I make a mistake, please tell me. Okay. Well, what am I going to do to simulate as if Q2 were there? I'm ripping it out, but how am I going to modify my existing machine? I think I got to simulate as if I could have chosen to go through Q2 and did some stuff with that. Okay, well, what are the possible ways of entering Q2 from somewhere else? From somewhere else. Because I'm ripping Q2 out, that self-loop's not going to matter in terms of entering Q2, the thing that's leaving. But where can I get to from somewhere else? Q0, that's the only place. So I'm going to make a list in Q0. Sorry, Q2. The only one is Q0. What about leaving to somewhere else? Q1, I think it's the only place. There is a subloop there, but it's going to go away anyway. So I'm going to make a list out Q2. There's only Q1. Okay. Well, how many transitions am I going to add? How many? I have one way in and one way out. How many? Yeah, I'm only going to add one transition. All the ways in times all the ways out is 1 times 1 is equal. So I'm going to make a transition from Q0 to Q1 on something. So let's figure out what that is. So Q0 is that we're going to simulate as if we went into Q2, then back out to Q1. Okay, well, how did I get from Q0 to Q2 before? Yeah, just a single A. Yeah. So I just have a single A there. Did Q2 have a loop? Yeah, it had the loop on B. So how do I simulate that as a regular expression? B star, yeah. So I'm going to put parentheses. It's not necessary in this case, but I'm going to put a star. B star. But then how do I get back to Q1? A union B. So in parentheses, I'm going to put A union B. And so now I've got to make a transition from 0 to 1 on this. Oh wait, there already is a transition there. What do I do? I'm going to union it, right? I could have chosen the B path, or I could have chosen this more convoluted path, right? I could have chosen either one. So the transition label is going to now be B union this guy. So A, B star, A union B. Okay. Cool. So now we got to figure out what next state to rip out. Any choice? Q1, that's perfectly fine. So let's rip out Q1. So every other state's going to still be there. So QS is there, Q0 is there, QF is still there. And so and obviously all the transitions that didn't involve Q1, but there was only one that didn't involve it. So what are all the possible ways to enter Q1 from somewhere else? Well, I can get there from Q0 anywhere else? No, so that's the only one. So in Q1, I'm going to make a list. It is only Q0, Q6, Q0. Anywhere I can get to from Q1 to somewhere else. Can I go anywhere else from Q1? I can go to Q0. Oh, and QF also on epsilon. So I can go to Q0 and QF. So how many transitions am I going to make? 2. Yeah. All right. Let's do the first one, Q0 to Q0. So we're thinking Q0 into Q1, back out to Q0. So purely for the interest of making my life easier and your life easier, I'm going to call this regular expression that we computed R1. So we don't have to re-put it in every single time. Okay, well, how do I get from 0 to 1? How do I get from Q0 to Q1? R1. Oh, R1, all right. See, it's so much easier to write R1 than writing the whole thing again. Did Q1 have a loop? Nope, so we're totally fine there. How about 1 back to 0? Just a single A. Yep. So R1A. So Q0, I'm going to make a transition back to Q0. Oh, I think that's a self-loop, right? Q0 back to Q0. And luckily, there isn't one already here, so I'm just going to add a self-loop right there to be R1. Okay? Let's do Q0F. So Q0 into Q1, back out to QF. I think Q0 into Q1 is still going to be the same, R1. And again, Q1 still doesn't have a loop, as far as I can tell. So we're already done with that. How do I get from 1 to F? Epsilon. And there it is. So now I got to make a transition directly from 0 to F on what? R1, thank you. So I go directly there. Okay. Are we done? No. How many more states to rip out? 1. Awesome. So we only have one choice to make. So let's rip Q0, QS here, QF over here. And when you start getting good at this, or mildly good at this, you notice that if you have something like this, I think I don't need to keep these lists anymore. So what do you think the final transition is going to be?
R1A star, cat A star.
Yeah, because I have nothing coming in, R1A star, and then R1F again. Cool. So R1A star R1. Is that the regular expression that we wanted?
Yeah.
Is this a valid regular expression? Let's be careful. Is this a valid regular expression? No, what is it?
It's the expression here.
It's a G and FA, right? What's the regular expression that I want? Yeah, the thing on the transition layer, right? So the most important part of this is knowing that the regex is R1A star R1. So the important thing to realize from this is to note the difference between a GNFA and the actual result that you want. I've seen countless students circle this and say that's the regex, when it clearly isn't. You can say it's the thing on the transition, but you have to be sure this is the thing that I actually wanted to get, not the GNFA at the end. Okay? It's kind of like in programming, like if you want to match the contract exactly, or like the API exactly, we're saying we want a regex at the end, so we better give a regex at the end. Okay? Any questions about any of that? All right, so let's do the third one. So I need a little bit more room, because that's more states. Okay. So this one has 4 states. Q0, B, B, and A. Yeah, I think that's the GNFA, it's not the GNFA, the NFA that we want to convert into a regex. So this is problem 3. So now I want to convert it to a regex, so what's the first step I need to do?
Add your new start and final state.
Add a new start and final states to make it a GNFA, so I'm just going to make some extra room. So convert to GNFA. So I got to add a new start state QS with an epsilon transition to the old start state. And all the previous final states are no longer final because we have a new final state QF. The old final state's epsilon to QF, just like before. And all the other transitions stay with. And this one's right here. And this A comma B transition, again, like the earlier one, I'm going to transform that into A union B to make my life easy. So A union B. And Q2 has self loop, epsilon into here. This is B. Okay. Next. So, what's the step we need to do now? I think we got a better rip states out, right? So, any suggestion as to what state to rip out? Q3, and any particular reason? Yeah, even more importantly, it only has one way in and one way out. So how many transitions am I going to add? Only one, right? What if you chose Q0 instead? Well, let's see, how many ways in? There's one way in, 2 ways in, so that's 2. How many ways out to somewhere else? 1, 2, 3. How many transitions would I add? 6. Actually, a recitation section really did choose Q0. So, and that took a lot of time to do that. So, obviously I could have chosen Q0 and it would have worked, but I want to make my life as easy as I can, so let's just choose easy ones to make for the interest of time. So let's do Q3. I think that'll be easy. And it ends up making the other transitions easier too. And can we figure out what the label's going to be from where to where? Just by looking at this. Well, it's going to go from where to where? The to the final, right? On what's regular expression? It would be star, right? Because it's epsilon, B star, epsilon, which is B star. So we can, I'll do it anyway. So I could have just done it directly on here, but I'm going to copy and paste it anyway. So QS, Q0, Q1, Q2, Q n. A, B, B, oh no, that's A. A, A, and Q2 to QF, like we said, on B star. Okay. That makes it a little easier. Now, what state to remove? Do you think? Oh no, I have got a transition. Actually, that's good exercise. What if I left out that A transition from 0 to 2? What state would be good to remove? 2, and why is that?
It's unreachable.
It's completely unreachable, right? How many transitions would I be adding at the end? 0, because there's no way into Q2 from somewhere else. But by adding this transition that I should have added at the start, now we actually, it's non-trivial to rip Q2 out. But any choice as to what state to remove now? Any choice? Either Q2 or Q1. Let's do Q2. All right, because you allowed me to have that choice. All right, so let's rip Q2. So now we have something a little bit more non-trivial. So what are all the ways into Q2 from somewhere else? Q0, that's the only place from somewhere else. Oh, not rip Q2. In Q2. Out Q2. Where can I get to from Q2 to somewhere else? Q1 and I think QF also. So I think we're going to be adding 2 transitions. So, oh, I should make this rip Q2. So I'm going to have all the states as before. So Q0, Q1, go Q2, Qf, final, epsilon in, B, A, and everything else falls B. All right, so let's do the first transition, Q0 to Q1. So Q0 into Q2, back out to Q1. So what is that transition gonna look like? How do I get from 0 to 2? Yeah, just A by itself, easy. Is there a loop on 2? Yep, there is a loop, and it says A on there, so what am I gonna add? A star. All right, A star. How do I get from 2 back to 1? Oh, sorry, yeah, 2 back to 1. How do we get from 2 back to 1? Two back to 1. How do I get there? A to B, thank you. Thought you were falling asleep on me. All right, so I think I'm going to be adding a label from 0 to 1 on this guy. Oh, I already have a label there. What do? Union. Good. So A union this guy. A star, A union B, and I'm going to call this R1 to make my life easy.
Can we rename A star to A plus?
You can, but I want to stick to the now erased definition as much as I can. Any other questions so far? Okay, but you can in general. It's just easier for me to look at it this way. All right, so the other one is 0 to F. So Q0 into Q2, back out to QF. Well, I think 0 to 2 is still going to be A. And the self loop on 2 is also going to be A, so that'll be A star again. How do I get from 2 to F? B star, yeah. So B star. So I'm going to add a label from 0 to F on that regular expression. Oh, I already have one there. Yeah. Thank you. I put it on the wrong thing. See, I make mistakes. So point mistakes out to me when I make them. So B union A star, A union B. Thank you very much. But I think I'm going to be unioning this with 0 to F. But it already has the epsilon there, so I'm going to union it with A star, B star. Okay. Nice. So we added all those transitions. So now what state to remove? Which one seems easier? Q1 seems easier because there's only one way in, one way out. So that's what we're going to do. Okie dokie. So let's rip Q1. So QS, and we can actually do this in place. We don't have to make a new list or anything. So this loop, QF's down here, and that transition is still epsilon union A star, B star. And everything else involves Q. So how do I find out what transition I'm going to be adding? From where to where? 0 to 0, yeah. So it's going to be a self loop, so I'm going to be unioning whatever it is with B. How do I find out what I'm going to be unioning it with?
The transition to and back to, or sorry, the transition from 0 to 1.
Okay, well it seems like I gotta do this transition concatenated with the transition back because there's no loop on 1. Good. So the transition is going to be B union this guy. So it's going to be B union A. Did I name it something?
I haven't named it anything.
Okay, I'll name it here. A star, A union B. But then I gotta concatenate this entire thing with A because I gotta get back to Q0. So I gotta concatenate this with A. Cool. And I'm gonna call this top one R1 and then this second one R2. Okay? So, what state to remove? 0. That's the only one I can remove. So, Q0. So QS and QF are the whole final state. And draw it. Definitely going to have a single transition, but on what? What's the transition going to be? R1 star. Then what? R2, thank you. So it's R1 star, R2, because it's epsilon, R1 star, then down to R2, to QF. So the regex we want is R1 star, R2. Okay. Any questions on how we were able to do that? So I have 7 more minutes, so I can either do some pumping lemma examples, or we can do some of the homework solutions from homework 1. If you're curious about that, or
You guys are on the slide sheet.
yeah, it should be floating around. So, what do you guys want to cover? Is there anything specific? What's there? Okay, so pumping lemma. So what was pumping lemma used for again?
Determining if something's is a regular length.
So it's very close. So both of those are very close, but it's not quite there. So pumping lemma says that if you have a regular language, then I can say things. But if I have language with the property that if those certain things are not true, then there's no way it could have been regular. Because if it were, then it would have satisfied those things. All right, so it only says things about regular language directly. But we can use proof by contradiction to prove something's not regular indirectly using the pumping lemma. So let's see if I can think of a nice example. Okay, yeah, that's a good one. So let's do this language. So I'm going to consider all W's in 0, 1 star, as usual, such that the number of zeros in, I'll do it the other way. Number of ones in W is twice number of zeros in W. And I claim that that's not regular. So what do I need to do to be able to show that this is not regular?
Show the complement that doesn't hold.
Yeah, show the complement doesn't hold, but how do I start doing that?
Choose a string.
Yeah, I better choose a string. Well, first of all, I gotta assume it is regular, then the punctuation holds. So I'm gonna call this thing L. So assume L is regular, then there exists a pumping length P for L. Right? There exists this constant for L. Then now, as the suggestion was, I gotta choose a string. But now I gotta figure out what string to pick. So what are the two important properties of this string that I have to pick? Can I pick 0, 1, 1? Is this has length longer than P? Maybe, I don't know. Can I guarantee it though? No. So I can't use that string, so because it's not long enough. What about 0 to the P1? Does that have length at least P?
Yes.
Yeah, but is it in the language? No, because I don't have exactly 2 P1s, which is what I would need here. So I gotta have a string that's in the language and has length at least P. So I swear, those two things are the number one mistake students make, is that you don't pick a string that's in the language or that is long enough. So what's a good string that I can pick that is in the language and is long enough?
E and 2.
Yeah.
0 P and 2 P1.
Yeah, so I would have P zeros, then 2 P1s. That's certainly in the language and is long enough. Whether or not this string works is, we gotta figure it out, but at least it could work. Okay, well, let's see. So, what do I have to do next? I gotta show, well, the pumping limit says that there is a way to pump this string, given that L is regular. But if I wanna show something is not regular, I better show that there's no way you could possibly pump this string. There's no way to break this string up so that you can pump it. There's no possible way. So we gotta think of all possible ways to break this string up into the X, Y, Z parts. So how do I do that? Well, where are the X and Y parts? They're all in the zeros. And why is that true? Because X, Y is a prefix of the string that we want, and they can't have length more than P. So it can't live, the X and Y can't be outside of this set of zeros. They may be all of the zeros, or a very few number of zeros, but I know they can't ever hit the ones. Okay, well, then we know that X is equal to some number of zeros, but again, I gotta handle every case, so it's just some number. So let's just say it's A, number of zeros. Y, again, I don't know how many zeros it has, so let's just say it has B zeros. But what do we know about Z or Z? Well, it has to be the rest of the string, right? Because I'm only breaking up into 3 things. So Z has to be the rest of the string. Well, I took away A zeros at the beginning, then took B more zeros. So I'm left with P minus A minus B zeros left over, and then all the ones, because I never hit the ones with X or Y. Okay? So now what do I gotta do? Well, I gotta show you that there is some, I can pump some number of Y's in to get out of the language, because the lemma says that every number of Y that you can pick, you can stick into the string, it'll always stay in the language, always. But if I can find you one value of the number of Y's, that at which point we can get out of the language, then we have shown that it's not regular. So any value, so what value of I do you want to pick? 2. So let's pick 2. It'll work in this case. Actually, you can prove that any value other than 1 will work. So let's pick xy squared z. So 2 copies of y in the middle. Well, the x part I know, so it's just 0 to a. 2 copies of y, well, that's just 0 to the b twice. So 0 to the b, 0 to the b. And then just the z part, which is just this part. So 0 to the p minus a minus b, 1 minus 1. All right, so I got to finish this up quick. So what does this collapse down to? Well, the a's will disappear, so those will go away. One of the b's will disappear. So I think at the end of the day, I have p plus b zeros. So p plus b, 1 to the 2p. That's what's left over. So what is the only way that this could possibly be in the language? Well, let's just be sure. Well, I had better have twice as many ones as zeros. So that means 2 times the number of zeros better be equal to 2p. Well, if we just expand this, that's just 2p plus 2b equals 2p. Then subtract 2p on both sides. 2b is equal to 0, therefore b must be equal to 0. But can that happen? No, obviously, because I better have y being non-empty. Okay. Any questions on how we were able to do that? All right, I'll see you next week.